I'll now request Dr. T.G. Sunndara Raman for his keynote speaker, uh, who is for this morning. He is PhD postdoctorate from IIT Madras, served in Bell, IBL, SPB, L&T and Comex, instrumental in getting renewable energy certificate for pulp and paper mill, carried out energy. Can you please give the laptop? Okay. Carried out energy conservation successfully in diverse industrial sector. And he is a member of several committees, have couple of patents in his name. Let me tell you in one sentence, Dr. Ram is an authority on energy in the country and in particularly for paper industry. So let's welcome Dr. Ram.
Good morning, everyone all. I thank IPTA, Mr. Ganesh Pati and Mr. Goel. This is an honor for me to be in the state of Gujarat, where I always call it a place of innovation. Right from Prime Minister's time, and I had a chance to get the award from our Honorable Minister, Mr. Piyush Goyal, some time back. I also made a point that we will do something from the pulp and paper sector to be number one, sir, as I am telling. As I said, as our Honorable PM was talking about, Make in India. So I feel it's an honor. We in pulp and paper do everything whatever we have done from Make in India. It's being done, whatever we do here, more or less it's an indigenous one. Whether it's the energy, I always couple it's an honor. Energy, environment and emission. Emission means carbon emission, your GHG. So whenever I talk about emission, it's always a GHG emission. So the three E's have to go side by side, together. So when I talk about innovation, as the next point is investment. Can you go with the as much as minimum investment but the maximum return, which gives you the best attractive ROI. And with all those things, investment, you must implement. So the implementation should be more effective so that ultimately you result in the highest of the productivity. When I say productivity, it is not the final production. What is the final product? From the initial, what is called the base resources. Sir, I thought I will share with you, being in the committee of the WRI and basically on the BAT, most of you would have heard, and in the B, heading the panel there, I thought I will share with you what is happening and how the government is taking it forward. What are the things we have a challenge? Because this address I thought is not general. It's a very important point which has come about. Last few months back when we met, we had a PwC report stating that the pulp and paper has come out to be the second next to the what you call the thermal power plants in terms of emission. So it has become a challenge taking that the vision of 2030 by our what you call our Honorable Prime Minister. The reduction he has contemplated for 2070 is your net zero emission. All of you are aware. That's what we are committed. In the COP meet is going on. But the commitment he has made it is 45% reduction has to be done by the industries. Of which the major sector, if you see most of you are aware, when I talk about what is called the CO2 emission per, we are supposed to give about 40 million tons we are committed by 2030. 40 million is a huge amount. The report says out of 2,170 we are supposed to reduce by more than 50%, assuming that the paper production will go up by 100%. If that is the case, which is not going to happen in reality, which means our commitment is 100% reduction of emission, which is almost impossible. But still, are we in a position to do that? Yes. You see some of these things. I think why I am talking about PAT is We always say perform, achieve, and trade is only for the elite guys or 40 guys. Out of the 500 and odd mills, only 48 mills are what you call have got a target to be reduced on the energy scale. Energy has become a major source, what you call the cost in terms of the final product. Out of this 7,000, see initially the component was 30,000 MTOE per ton. Now it has become 20,000. Very shortly the government is contemplating to go for 7,500, which means from 40, 250 mills are going to come in terms of specific energy reduction to be done. If that has to be the case, I thought I'll go into the subject proper. This is general overview of the paper well. Whether we have some of them have with the recovery integrated mill, some of them have the other. If that is the case, what are the areas we can look in for? Yes, one is on the, we talk about simply what is the energy mix we have. We talk in terms of energy. The energy we say is what is fuel, the other one from the fuel, we get both steam as well as power. The fuel can be from coal, lignite, and in Kutch, we talk about the Kutch Vanandaro lignite. To go down south is the Neyveli lignite. And we have either the grid power be imported or exported. If this is a combination, we have either the coal or the biomass. Or the third one, some of you have the recovery boilers, we call it the black liquor solids. I'm happy to state, with great effort, right, we have put in a case of the black liquor solids to become renewable. After a very great deliberation, we got it certified as a renewable source. Most of you are aware. If most of you are having the recovery boilers, you can go with the renewable route of black liquor. But there is a compulsion to use biomass in the boiler to replace coal. If I go to the next. So the simple forms of energy what we have what is called the fuel. From fuel, you have got two routes. Either you go to steam and the thermal. Why I am writing thermal is most of you are aware. Apart from steam, you use lime kiln where you use thermal route, which is your furnace oil, biogas as the case may be. The third one is power. These are the two things which happens in the pulp and paper. If that is the case, from the steam, you are aware we have the high pressure steam, because the high pressure steam nowadays is going for power generation, cogeneration. And next level is the medium pressure, which is your 10 bar, 150 psi. The third one is a low pressure steam, which is your 50 psi. I am introducing one more term, which is a low steam pressure, which is going to be still lower, and trying to put down. That is also going to be evolved very soon, which is what I am working on it. And this will cater to down the line like near 18 others. If these are the four forms of steam which is going in the power, this is what is contributing in terms of energy. As far as energy available from the process, what is energy available from the process? You see whether you produce power or you produce steam, correct? This is not going to be available for the process. You produce power. Out of that, you have what is called the auxiliary power consumption, like pump, driving, to make the boiler run, to make the turbine run. You have to raise what in terms of power consumption, which is called the auxiliary power consumption. Similarly, for auxiliary steam consumption, you have the route, you produce steam. Some of the steam you take it for deaerator, some of the steam for steam coil aerator, soup blowing. And the next steam and power which is going to be available for the process is what we are aiming at to maximize. Not what you produce. You produce 100% out of that, 20% is totally lost. How you can maximize my net steam power to the process? So two main things I evolve. I always talk about what is called the climate change, which is very well within those things. You always talk about global warming, where we talk about decarbonization, how to reduce net power, those things, emission reduction from energy. The other one coined a new term. Sir, there is a waste energy which is going out the sky in the pulp and paper mainly. And This is one form of energy, more than what we talk about, solar, hydrogen. Sir, one form of energy which is available, which is not being utilized. That is one form. If this is not utilized, we have got what is called the local warming. And this is the target which I am going to talk about in this particular thing as a special question. If I take in the very broad skills, starting from source, then the process, and then the end of life. If you are going to talk about that, what is the source? Source is mainly the fuel for energy. That fuel can be any form, and that is going to be the input energy. So, okay, on the source, can I improve upon it? Either I reduce my carbon. See, kindly understand, most of you are not giving that importance to carbon in the fuel. Carbon in the fuel is only going to give you CO2. Nowadays, we purchase with heating value and doing. What is the carbon content? Is it, see, if it is going to be moisture related, the carbon content is going to be low. I am also going to tell the ministry because I am getting that in the BE. Sir, you have to give, don't always multiply whatever coal you get with some factor there. There are coals, earlier, sir, if you are aware, a lot of importance right from the sun. If I got a choice, can I reduce with the coal, global, what you call carbon content reduction? Next comes your process. When you talk about the process, what we talk is energy conservation or energy efficiency. You improve everything on the process side. The whole thing is happening in the process. What is the end of life? Everything is over, it is all over. Whatever is going to the sky is getting lost. Can I recapitulate that waste? That waste you see, it's a tremendous amount of waste which is getting available as a source of energy. If I am going to talk about, sir, this is the subject which is, I thought, is going to be very, very important. The major source of loss in paper industry, I can say, what are the three stacks or three pillars or three towers which is contributing. The first one is boiler stack, most of you are aware. Whatever is lost is the stack heat losses, which we will talk. The next one is from the cooling tower. That stack is losing all the latent heat from whatever you are losing. See, your condensing turbine and other things is hardly taking about 30%. What is coming into the turbine, what is leaving in the turbine is only giving you power. That is hardly a fraction of what is the input coming in. And rest of the things, most of you, if you see the condensing turbine being a cycle efficiency lower, all these things are getting lost into the sky. So the major losses is on the cooling tower. Can you hit on that cooling tower and improve upon it? The last one, which I thought is the expertise from you all. I have taken as a special subject. We have gone ahead. We are normally doing it in isolation. Correct? We talk about paper machines on group expertise. Like the cement plant. I used to talk to cement plant. You guys are world leaders in your cement because specific energy consumption is lower. But you talk about the fuel. In your power plant, you are totally off compared to even the pulp and paper. So you must have a marriage between the, what do you call, energy generation centers and energy consumption. In that case, you will see, on the paper machines, most of you are aware, whatever heat which is getting lost in terms of paper is tremendous because whatever steam you give, it is getting lost on the other side and the air is sucking the whole thing and taking it out. So, if you see the combination, how it's happening there, sorry, this is the quantum energy losses which is going into the atmosphere sky. If we talk about the efficiency of a boiler, you will say it's about 78-80%, the best of the boilers. You take a bagasse or biomass boilers, it can be 65-70. So the losses will vary from 22 to 40%. Is the losses happening in the boiler from the energy? So can we capture that portion? To what an extent we can capture and reduce? The second one you see is the condensing turbine. You see the losses is as high as 65 to 72. It can be higher also. So this is the amount of losses we are losing from the energy front. The third one is on the paper machine. Whatever steam you are giving it, except for what you preheat the air in the pocket ventilation in the hood, the rest of the things are getting lost here. I am talking generally in India. Of course, in foreign they are trying to recover that heat also to an extent. But basically, the quantum energy losses, if we are able to tackle simply, because all these things are waste. So waste energy in the paper mill is the major source. It does not go beyond that, taken to hydrogen and solar, which is all future development. But here right now, if you are able to pick up this and convert it, that's the greatest opportunity you are getting. Now we go into the main subject. Here I will take time. Okay, you have talked about so many things on the losses. Can you contribute in terms of what are the areas you think where some of us can take it back? So kindly if you see, and dividing into boiler complex because we stack losses, TG complex because we talk about the condensing and the back pressure turbine, and then the auxiliary power consumption or auxiliary steam consumption, where you have got the net steam and power. The last one is your line cable. If I talk about that, simply faster. First one is flue gas loss. As you said, the boiler stack loss can be improved by reducing the flue gas temperature and take the what you call the choice of the coal. And as I told you about the C by H ratio. The second one is the drying. Most of you are aware, some of the cases the flue gas drying or the belt drying where high moisture fuel can be picked up, the heat can be picked up by reducing the moisture, increasing the boiler efficiency by the waste heat which is coming out from the flue gas. That is your drying of the fuel. And the next one what we talk about is the solar drying, which only happening in Gujarat, like they do the what you call the Kutch lignite protection. Very few places are going on solar. And then the renewable energy option, switching over to renewable energy, which gives you the advantage in terms of the climate change improvement and the energy cost reduction. The second one what we talk about is the turbine. So most of you are aware, as I said, can I improve upon the turbine? Yes, the generator efficiency can be maximized. The other one I thought I'll share with you. Generator cooling, why should I use normal cooling water and throw it to the cooling tower? Why not I have the alternate and just sharing with you? Putting out, you put your PM water and condensate and take the recover the heat and reduce your daily testing consumption, which means the generator efficiency has gone to 100%. If it is 96%, even the 4% can be recovered from that in terms of useful. What is wasted to the cooling tower, you are maximizing in terms of power. Then the turbine itself designed, I was just talking to this thing. So when you design the turbine, in the back pressure turbine, we say the cycle efficiency is very high. Cycle efficiency is not very high. The turbine produces power from the entry to the exit of the nozzle, which is hardly 100 kilocalories out of the 700. Rest of the things goes to the process or your PRDS or something. If you are able to design a turbine in such a way that you maximize your power across the nozzles, turbine nozzles, you get that extra additional power in terms of, you go to high pressure steam, I don't want, most of the cases you will find, after the turbine, you will put some de-superheating and reduce. Why should I do? If I do a proper turbine, what you call design, you can definitely get the maximum out of it. The next one, most important which you have done, is the dryness fraction. Most of us are unaware what is the steam quality which is getting into the cooling tower, condensing. Some of the things I have seen, it is superheated steam which is going, which means about 30% of the heat is getting lost in the case of high. So if I am able to maintain a dryness fraction of 90% or 92, which has been done in one of the plants, you get a recovery of another 20% increase in the power generation. So why? See, there's no investment. You do the whole thing and get the best out of it. So if I take to the paper machine, which is what all the experts are here, I just want to share. Paper machine, I put the stick, I concentrate only on producing the paper. On the wet end, you try to reduce the moisture as low as possible, which is what the Westerners have done. Here also, cases is cool, improved. Instead of what you call drying in the cylinder side, you take the moisture out from the wet end section. The second one is on the drying cylinders. When you have the drying cylinders, all the drying cylinders are exposed. If I am able to cover the drying cylinders with the insulating cover of the, now Ugam has come out to the paint. If you are able to cover, you get another 5% increase or reduction in the steam consumption or output. The last one, which I will be discussing mostly in the paper. See, you give air and take the steam vapor which is formed and throwing out into the sky, which I showed you in the beginning. So instead of steam, instead of air, can I think of steam air mixture and reduce your entire, what you call, you start generating low, what you call, very low pressure steam out of the turbine, what is coming into the paper machine. Can I get mileage out of this? This will have a quantum reduction. The third one is the actual power consumption, steam consumption. Most of you are familiar. You have what you call best energy efficient pump, you have got the energy efficient fan, and such a lot of these things. And then you talk, even the air compressor. So air compressor is one case where you always say is the energy guzzling. So we made it a point, in the air compressor, whatever heat is coming out is a waste. If I am able to convert the heat, which is being done, to make it to hot water, reduce your dehydrated steam consumption, air compressor has recovered its heat and converted it into power. So you are able to save from the compressor also. Then you have a steam consumption in the dehydrator. Most of you are not aware. You always talk about HP steam. HP steam is taking from the dehydrator steam outlet to this. Who is going to have that heat from the base temperature to 130 or 135 degrees? This is a substantial amount of dehydrator steam consumption. If attempts can be focused, you can certainly reduce your dehydrator steam consumption. Next one is the steam soup blowing. Instead of using the high pressure steam soup blowing, nowadays we are planning, we are getting it through the turbine and take that one, you get the power, and then the balance goes for steam soup blowing. The other important thing is PRDS. PRDS is only killing the pressure. So what we thought is, wherever the PRDS is here, replace it with the energy conserving turbine. So there is no question of pressure reducing. Pressure should be reduced through the turbine or expanded, and in terms of power. The last one, which is being very important here, is a hot water generated 90 degrees can be used for RAM. They come up with this thing, RAM, how it can be done. And the next point, of course, I need not talk more on line killing. Biogas switch over to from the side. A belt dryer for line kill market to be gold. And the other very important thing is radiation convection losses. Insulation plays a very important point in the energy loss going up. The one point which can do is, you strengthen the insulation at what you call lower flow. See, when the whole, people are designing the whole insulation pipe to save on the pipe, and if the temperature drop is going to be 5 degrees or so, it doubles up when the load is going to be lower, because insulation loss, the surface temperature is always smaller. So we always say, give importance to insulation, whether it is boiler to TG or elsewhere as such. That gives you added advantage in terms of energy recovery. When I go to the next one, this is all just to give an idea. What is the fossil fuel complex over here? I'm talking from the Kutch lignite to the Neyveli lignite or the high ash power, the imported coal or the HFO. These are the combinations we have. One is high moisture, where you have the stack losses higher. High ash coal, you have the other problems. And then HFO, you have the sulfur problem. With all these fuels which you have to play with on the fossils, the bio is also coming with a very, this is a list of bio waste which I have picked up, and which is all high moisture. If it is going to be high moisture, it's all the waste. Can you not, what you call, reduce the moisture by the flue gas and increase your boiler efficiency? So we take one of the subjects. Sir, all of you might be aware, the mandatory law has come that every boiler CPP has to take 20% biomass offset of coal or liquid case. When I talk about 20%, I wanted to be very clear. 20% you just put a biomass is not going to solve. 20% by why? If you are going to talk about, you talk first of all what is the thermal energy in the fuel, which is a heating value into that. What is going to be the net output coming out from the biomass is the efficiency. So you are talking about renewable energy conversion with more amount of biomass which has to come to replace 20% coal offset. This is the what you call the theory which the government is thinking. I also want to clarify. Government is asking for 20% offset from the renewable energy converted, not what you dump the biomass in terms of weight. It's just like your volume basis. The typical case as I told you, because you say, can I reduce? If you are able to reduce one of the cases by the flue gas, the biomass, whatever you call it, 50% the gas width of the case may be, you can, what you call, substantially get not on the fuel saving and also the efficiency and finally your carbon reduction. This is the drying part of the flue gas which is going out of the sky. As I told you, what is the obligation of the government? If your central policy of switching over to biofuel for even for the pulp, all the industrial boilers throughout the country, you will get about 3 million tons of carbon dioxide 8 million rather, for all the industries. But when you take only for the paper mills, we give a contribution of 2 million, which is substantial when we talk about recovery of it. So this point is very important because we talk about energy cost reduction. We always, everyone talks high pressure steam. What is the steam cost? Steam to fuel. First of all, I am saying steam to fuel is not the actual cost. The notional cost, if you see, if you take all the areas, is when I produce steam, I have to produce steam for the deaerated steam has to be costed for. We have the auxiliary power consumption, which has to be costed for. Auxiliary steam consumption has to be costed for. Then you have a DM water also has to be costed for. Then the radiation convection losses and all the other losses and all those chemicals which are named, if you are able to add all the costs, that is the cost with which your steam or power is being produced. If you take it, it is going to be, sir, it's going to be very, very high value assets. The same thing happens for grid or export power, which is not to be taken as notional. If you take it as actual, then you will see what sort of impact energy makes when you start reducing that. The net energy, net steam to the power is for this one, has to be costed for. This one I'll just skip through because we have already discussed so much on this auxiliary steam consumption and power consumption. Most of you would have done this. It is not what you call a Herculean task in this particular case. But the most important thing is, as I told you for generator cooler, I was just suggesting, why do you use the cooling water there? You have the turbine condensate available. You have the DM water is available. Why not you pass that water through the generator cooler, air cooler, and get that heat so that it need not be thrown to cooling tower. You make extra power out of the generator itself. So when I talk about upward, because we talk about alternate sources which are available, one is solar, and the waste. When you talk about solar, don't go only for solar, rooftop and everything. There are versions like concentrated solar where you get a pickup of higher solar thermal, which can be heating even the water to as high as 90 degrees plus. And then solar drying of fuel, all of you are aware. And then for the van, hydrogen energy, I was just requesting Dr. Gupta, can we not take it in CPTRI? Okay, everyone is doing it, right? And I thought it's the best center because we have chemical engineers of the field. It's basically a chemical mechanical one. We guys should take the lead on the hydrogen energy. I was just giving a forethought. We also should start inculcating like our paper expert, right? Hydrogen energy should also be form a part from the CPTRI. We can definitely contribute with our knowledge because we know what is required for the pulp and paper, not the other things. And most of you should be aware the carbon trading is started with the Energy Conservation Act. Earlier it was CDM, BCS and all those things. Now they are mandatory as such a carbon trading has started. The number is going to be fixed and the trading philosophy, all those things will come up. And is whatever you are going to earn in terms of energy can be certified in terms of carbon trading. When I talk about decarbonization, every time I talk about decarbonization, it's how fast we accelerate net zero emission. Net zero emission is quite far off, but still, certainly we guys can do in the pulp and paper. First one is, as you all are aware, renewable energy mix. We have time and again start. Keep on offsetting fossil fuel with the net, what do you call the renewable. Circular economy, I always call it a circular economy. Don't reduce the waste, keep on reducing. At one point of time, the waste should be converted to valued resource, which can, all this, whether you talk about the waste to the sky or waste to the earth, this maximization of waste should give you the best of the circular economy. What we talk about, this certainly can happen. And when you talk about specific energy consumption, when you talk about specific energy consumption, start from the fuel source right up to the product, whether it's going to be a pulp, paper, as the case may be. That should be reduced per ton of unit of product. And what some of you should be aware is what is called the absolute and specific. If you talk about, I talk about 50 milligrams, I'm getting it from 3 or 4 boilers with the lowest of efficiency. The other guy says, if I'm making it 50 milligrams with the efficiency of 60% boiler, you are throwing out more emission into the sky. If I'm going to operate the whole system with the higher efficiency of the boiler, The pollutants you are going to keep is going to be lowered by that extent, but still you will be maintaining the 50 milligram. So I am saying absolute emission also, it's a very important facet which you have to take care of. The scope 3 emission, some of you should be aware, they are not going to restrict only emission within the plant. Very shortly, the scope 3, which is outside your boundary, like your logistics. I push all the way from coal from Indonesia. Who is going to pay for the carbon? Which will definitely will come to our head very shortly, because if it's, people are going to really that. So can I have indigenously, whether you have biomass as the case may be, scope 3 emissions will be reduced. And the most important last point is bagasse-fired boilers. Sir, bagasse is going to come with a very important one. See, nowadays bagasse is burning. They say we get what we call good amount of energy, but the efficiency is so bad. If the paper mills can integrate the sugar mills close by, they got two advantages. If the bagasse efficiency of the boiler goes up, they can release bagasse for the paper plant for their use. Or the bagasse can be used as a renewable mix in their boilers so that they can offset your energy. So I suggest the integrated approach is the need of the hour. Integrated means, I just thought 2 minutes I'll just take. We are always having a segmental approach. I am very good in the paper machine and do all those things on the pulping paper machine, the guy in the recovery boiler will be just there, and the power plant will be doing independently. If we are going to integrate and marry our expertise in both, we will get the best out of this. That is why I said the integrated approach between either the power plant and the systems will have in common. The best of the results in terms of energy reduction certainly should result. And the knowledge sharing between the operating and the design people, I think it goes a long way in terms of energy being not only saved at a very high level. I was also suggesting vendors should be a partners in progress. I just order, he doesn't know what he is giving it, he just goes off. If he is going to be involved with you, he can suggest, suppose I have a turbine. I say you order a turbine. Suppose he is going to be involved with me, he can suggest what I require. See, I always agree or suggest, in case of turbine, it should be a backward integration. Turbine should design what is required, not the boiler. If this sort of approach is being taken, you get the best results in terms of both productivity as well as energy reduction and the emission reduction, whatever you call it. So, to cut it short, because the time is short and we are talking about a broad sense, I call it as B. Nothing is, water cannot be taken out of the sea. Water is going to be a very important commodity. Water conservation, energy management, environment. You can't do it without environment. Environment, I talked about, the emission and all these things. Last one is your carbon emission reduction. If all these things are continuing, you have to continue on sustained basis as such to get the best of the goal. What we plan to do. See, this one subject which I really close to my heart. Energy, environment and emission reduction. What I have pledged the last few months when I was there with the BE and those things. Sir, pulp and paper, you have put second as the worst commuter in terms of emission. We will be the first, come, I think all of you can join. We will be the first to achieve net zero emission even before 2030. And that is possible because we have an entire biomass available. We have got all the base which are available. We have got the technology available. We have got the brain behind available here. We need not go out of the country. We can make in India, achieve the net zero emission. This is what the Prime Minister's goal or vision is there. I think with this, I thank the people for giving not only this opportunity, it's an honor for me to be at this state where the innovation has started. And the innovation will continue and innovation will spread. And I was very happy. I wanted to have the minister, because I saw Minister of Energy. I think he would have definitely appreciated some of the points, how we can take the lead. I thought it's, thank you once again for both the IPTA and the participants who have come in large numbers. When you go back, if you can pick up some things which is of beneficial to you, and IPTA has done the job as such. Thank you so much.